All right, so just started the recording. All right, so again, welcome all. So glad you can be joining us this afternoon. To get started, I just ask that if you put yourselves on mute during the presentation, and if you do have a question, you can unmute yourself. We just don't want any like unnecessary background noise disturbing others for the presentation. You can unmute yourself to ask a question, that's totally fine. Or you can type it in the chat, or me or my assistant Mike will gladly answer your question. If you do need to leave early for whatever reason, that's totally fine. I will not take it personally. And yeah, so thank you all for joining, and let's get started. All right, so a little introduction to myself. My name is Mikey. I am originally from Miami, Florida. I am currently serving with the Squam Lakes Association as a Lakes Region Conservation Corps member. Our goal here is to conserve the beauty and the natural beauty of Squam Lakes through conservation, trails and access, and like educational programs such as the one you are joining us for right now. I studied biology at Florida State University and graduated in 2018 with a bachelor's degree from there. And just some things that I like to do, I love to go hiking, reading a book, or even just being in the kitchen trying a new recipe out. With me, I have my fellow LRCC member, Mike, who's gonna turn on his camera for a moment. He's gonna just let other people in throughout the meeting if they arrive late, or answer your questions in the chat. He has the chat open, and he'll inform me if there's any questions that you have. So yeah, let's go ahead and get started. All right, winter aquatic ecology. So just to break that down, winter, the time of the year that we are in currently, when the days are shorter, temperatures are colder, and it just snows, and it's great. Aquatic meaning water, ecology meaning the interactions of animals and plants and all life organisms and with their surroundings. So winter aquatic ecology. So just so there's no confusion, what causes winter? A simple question you might think, but in fact, there could be some confusion. Winter is caused by the seasonality of the Earth, rather, is caused by the tilt of the Earth on its axis. The Earth tilts at about 23 degrees in either direction constantly, and as it rotates around the sun, that means that the poles are either pointed towards or away from the Earth. So while it's winter here in the northern hemisphere, it's actually going to be summer in the southern hemisphere. As a result, we're going to have shorter days and less solarization from the sun during the winter months in the northern hemisphere, while the southern hemisphere is having the opposite. They're having their summer, so they're going to have longer days, a lot more sunlight, and thus a lot more productivity from plants and organisms like that. So I found this cool video that I wanted to share with you from the California Academy of Sciences that does a good job of summarizing this phenomenon of seasonality on Earth. So bear with me. Hopefully last time we didn't start. Okay, beautiful. You gotta just be quiet.
You know that Earth orbits the sun, right? And that it takes a full year for our planet to complete its orbit. Earth also rotates like a slightly tilted spinning top. Earth remains tilted in the same direction all year around as we orbit the sun. But that means the sun's light shines differently on Earth at different times of the year. Let's look at Earth when it's winter in the northern hemisphere. Observe how the North Pole tips away from the sun. This means that sunlight strikes the northern hemisphere at a shallow angle for a short period of time. This is why winter weather is generally cool, with with short days and long nights. As Earth orbits the sun, we move towards spring in the northern hemisphere. Now Earth is tilted neither toward nor away from the sun, as day and night are about equal in length. As we make our way to the summer months, notice that Earth is still tilted in the same direction, only now on the other side of our orbit. The North Pole is tipping toward the sun. Sunlight strikes the northern hemisphere more directly, and the sun stays in the sky for a longer time. Compared to winter, summer days are warmer, and the sun stays in the sky much longer. Notice too that while it's summer in the northern hemisphere, it's winter in the southern hemisphere. Because of Earth's tilt, the seasons are reversed. We observed how Earth's tilt creates the different seasons throughout the year. How does this affect life? Plant life and other photosynthesizers, we call them primary producers, depend on sunlight. They respond to the changes in the seasons. Earth-orbiting satellites measure the amount of carbon dioxide absorbed by these primary producers. Bright regions on this map show where they devour the most carbon dioxide, turning light from the sun into oxygen and natural sugars. In spring, when sunshine strikes the cold waters of the North Pacific, productivity skyrockets. Phytoplankton and other microscopic photosynthesizers form the base of the ocean food web, and all ocean life responds to changes in the seasons. On land, forests grow green during the spring, brightening the continents. During winter, continents in this view turn dark from a lack of photosynthesis.
All right, so I think that does a really good job explaining what the amount of sunlight and just like the simple turning away of the Earth from, in the northern hemisphere, I should say, away from the sun can have a big impact on what we call productivity, the amount of carbon dioxide that plants are taking up. So I'll just rewind that part. So this is in November in the northern hemisphere, and go to December when the winter solstice is, we have very low rates of productivity, and thus we're having less, the plants are like having less access to sunlight, so they're making less food for themselves, and that, as you can imagine, can have huge ramifications down the food chain in terms of, you know, if herbivores aren't able to eat those plants, then the carnivores that eat the herbivores aren't able to sustain themselves as well. And thus we see lots of hibernation or migration to adjust to those changes in seasonality. Oh, okay, so we've talked about what causes winter and how the seasonality is a result of the Earth's tilt on its axis. Now I want to move on to, now that we established what causes that, other important aspects to winter life on a lake. I'm just going to mute this so we have it on in the background. And so a big consideration for aquatic ecology during the winter, as I'm sure you can imagine, is ice. Ice is huge in terms of what's going to happen to our ecosystems. The property of water that makes ice less dense than liquid water is essential for life to actually exist in aquatic ecosystems. Because if you think every year, if ice just like fell to the bottom of the lake and killed everything beneath it by either freezing or just crushing it, then we would not be able to sustain life within our freshwater aquatic ecosystems. So it's hugely important that ice is less dense than liquid water and can float on top of the ice. Besides it being less dense than ice and less dense than water and able to float to the top and keep everything liquid below it, ice acts as like a kind of an insulator, like a puffy jacket for a lake. You know, it keeps the water below the ice actually relatively warm. I mean, you know, not that I want to be in it, but it keeps it relatively warm for the fish and the other animals and plants that live there. So they're not going to freeze, and they're actually going to be able to survive there because the wind's not constantly churning up of that water. All right. Okay. All right, just to look at what's happening to water on a molecular level, you think of temperature or like high temperatures resulting in particles moving faster. That's basically what happens on a molecular level. As sunlight or any type of heat is beaming onto water, you see it with boiling water, bubbles start to form, water's moving very fast. And so as a result, they are moving really close to each other. And what we see in water is this intermolecular forces called hydrogen bonds. So different water molecules are actually attracted to each other because just the chemical properties attract them to each other in such a way that they're like very coherent to each other. As we start taking away that ambient temperature from water, what's actually happening is those molecules are slowing down, and the hydrogen bonds that keep them so close together actually repel the water molecules away from each other in a kind of hexagonal shape. And that results in a less dense formation of the water, or what we call ice. So ice is less dense because of this hydrogen bonding that happens on the molecular level. And as a result, ice floats up to the top, and water below still remains this semi-fast moving molecular soup, essentially. All right, limnology, which is essentially just the study of lakes from their physical, chemical, and biological components. Here on Squam Lake is a dimetic lake, which means it has 2 mixing events per year, in the fall and in the spring. And if I could just take a step back, imagine it's summer and the sun is beaming down on the lake. It's warming up that top layer of the lake. It's nice to swim in. It's comfortable for us and other organisms that like more warmer temperatures. What that results is this kind of this thermocline, or the stratification, where we have warmer temperatures on top, and then as we go down, it starts getting cooler, and then I'm just gonna get this smaller. What happens is it just gets very, very cold until the water reaches 4 degrees Celsius, which is the most dense water could ever be. So after it starts getting colder than 4 degrees Celsius, that's when ice is going to start to form. Not really, that ice forms at 0 degrees Celsius, but once it starts getting below 4 degrees Celsius, it has the properties of slowing down and being able to form ice. So it's going to start actually rising. And that's all I'll say. When we're at the bottom of the lake, the closest it's going to be is about 4 degrees Celsius. And that's going to result in the stratification, or this layering of the lake. So that's what it's going to look like during the summer. It's going to be all these different layers. As the fall comes and we have shorter days and it starts getting colder outside, that top layer is not going to be so warm anymore. It's actually going to start cooling down. As it cools down, it's going to get denser. As it gets denser, it's going to fall. It's going to cause this cyclical action of the colder water from the top is going to fall down and reach the bottom, and the bottom water is going to go back up and result in this kind of like turnover event. So that's going to actually result in some nutrients and microorganisms that have been living on the bottom of the lake to come back up the water column into the upper layers of the lake. And that's going to result in sometimes algal blooms and cyanobacteria events, which aren't good. But then they'll typically die off in the winter when it's too cold for them to exist. But that all leads into winter, when we have not a stratified lake, but just a very like ubiquitous, cohesive lake where there isn't really a layering of temperatures or even organisms and chemical components. It's pretty well mixed from the fall turnover event. And it stays that way all winter because, like I said, that ice remains as an insulator on top, so it's not kind of ginning up some good like mix-in events. And so it remains that way until the spring, where there's another turnover event because it starts getting warmer. And so kind of this cyclical action begins again until the summer, where it's consistently warm, and it's going to start this stratification layer and event all over again, and so on and so forth. And that's basically what we're going into winter with, this mentality that the water column is relatively cohesive throughout. And so that's not, when we think of like how life might be limited within the water during winter, it's not going to be because of nutrients or stuff like that in different parts. It's going to be pretty cohesive. It's going to be mostly temperatures and amount of sunlight that are going to make a big difference of like what's happening below the ice. All right, and so with that, let's move into our microorganisms. Microorganisms like phytoplankton, do you have a question? Could you explain more about the physics of what makes the layers turn? I still don't quite understand. Yeah, so if you think like a convection oven, you have hot air rises, right? So hot air, I can go back actually. Hot air is going to rise, and then as it cools, it's going to fall, get more dense, and come back to the bottom where it's going to get more. Oh, Mike has a good example, a lava lamp. So if you think of a lava lamp, it's going to get really hot at the base of the lamp where the light is coming from, and then it's going to come back up, and as it gets to the top, it's going to cool down and get denser. As it gets denser, it's going to fall back down where it will go back to the light when it's going to be warm again. So it's like the cyclical cycle, which is exactly what's happening in a convection oven and on the sun, and it happens all over in nature. Does that answer your question, Nancy? I'm going to move on. I hope it answered a little. Yeah, okay, great. The lava lamp helped. All right, so microorganisms, like I said, especially when there is ice out, we're going to have a lot lower levels of photosynthesis happening. And that the ice, in conjunction with like shorter days and just a smaller angle that the sun's going to hit this part of the earth, is going to reduce the amount of photosynthesis. And as I showed you in that first video, there's going to be less productivity. And so that's going to have a chain down reaction where phytoplankton, or phyto meaning light, plankton is like, you know, little animals, or not animals, microorganisms. They aren't going to be able to produce sugars to sustain themselves. So we're going to see a sharp drop down in those types of organisms. And most of them will either can remain dormant for a while, or either that, or like have spores, something like that, so that they'll come back in the spring when it's warmer and they have more access to sunlight. And as a result, other microorganisms that might eat that phytoplankton aren't going to be able to exist as well. And they have similar kind of mechanisms to survive the winter, whether it be being more dormant, or having their offspring come back in the spring. All right, so similarly to microorganisms, plants will also have less access to sunlight and thus not be able to photosynthesize more. But I'll just go through the different types of aquatic plants we see in our freshwater lakes. So in our first area, we have the Emergent Zone, which is kind of characterized by plants that are rooted in substrate and are usually erect and standing up out of the water. Good examples are cattails, pickleweed, grasses, rushes, and sedges. Basically things that are like along the banks of a lake or a river, for example, that have the roots partly in the water, but the main parts of their body, the leaves and stuff, are poking out pretty wide, or far out into the air. And then we have floating leaf zone, which is characterized by two types of plants, which are free floating, they don't have any roots, and those that are rooted, but they are floating on top of the water. Good examples are water lilies, floating heart duckweeds, and water shield. And so that makes up the floating leaf zone. And then there's the submergent zone. And I'm sure, as you can guess by the name of this area, these plants are completely submerged. They will sometimes produce flowers that are above the waterline, but for the most part, all their leaves and their roots and stuff like that remain below the waterline and completely submerged. So when we think of plants overwintering, the ones that have parts of their bodies outside of the above the waterline are not going to do so well. Or if they do overwinter, they senesce back or die back to their roots. So we're not going to see all this lush green and flowers and stuff above the waterline during that time. Most of them are going to die, release spores to come back into spring, or just senesce back to their roots. Whereas a lot of submerged plants will actually be able to survive the winter, because remember, it's going to stay relatively warm down there in the submerged area, and they're not going to be subjected to the winds and colder temperatures of the air. So what that's going to result in is plants that are submerged being able to be more hardy and survive the winter, whereas the emergent plants and floating plants are not going to be doing so well. And we'll have to wait till spring to come back. And another cool thing about winter in our lakes and stuff is that cold temperatures can usually do a good job of snuffing out any potential invasive species. I mean, that's not always the case. You think about variable milfoil, that is well adapted to our climate and can do well during the winter. And so there are exceptions, but if you think of like a plant that might be native to the southern United States, it's not going to be able to take root up here in New Hampshire because it's not going to be adapted to the colder temperatures and the lack of sunlight. And just like the microorganisms, the submerged plants are not going to be able to produce as much oxygen and be as productive as they are during spring and summer, but they are able to survive nonetheless. Okay, so invertebrates, they have a variety of adaptations to survive the winter. I have this playing in the background with the sound off just to give you a visual. Think of different invertebrates as things like this, like creepy crawly bugs, but there's also snails and mussels and things like that, aquatic organisms that survive in our aquatic systems here. And most of them will remain dormant throughout the winter. They don't take the chance of being subjected to the cold, but some of them are able to, I'm just trying to find the notes here. Some of them will actually hibernate through the winter as parasites and other organisms. Some remain active just below the ice. These invertebrates that you're looking at right now actually came from cold iced water, and they can survive in like more murky water. But yeah, they will do better when they are in like the mud. So most invertebrates are also going to, as they are cold-blooded, not going to be as, they're going to reduce their metabolisms rather to survive the winter. Okay, and fish, like our invertebrate friends, can also take on a variety of adaptations to survive the winter. They can either become can hibernate or become less active. Others will actually just reduce their metabolism, but still be able to swim around. I mean, you know, ice fishing is a thing for a reason because fish still are active. They just they reduce their metabolisms to be able to survive the winter. Other fish are able to create a antifreeze within their own bodies. to survive below 0 temperatures. And that typically only happens in marine organisms, but I wanted to show you this video anyways, because I think it's just such a cool feature, even though that's not really prevalent in freshwater lakes, as I told you, because typically we have ice that keeps things insulated. I think this is really cool to learn about. So I'm going to share this video with you about how this Antarctic fish can make a antifreeze within their own body. Ooh, turn the sound.
In the waters surrounding Antarctica, the water temperature never rises much above freezing. At minus 1.9 degrees Celsius, any normal fish would be a fishsicle. But this fish seems happy enough. How? It has a type of antifreeze in its blood. It's a notaphenioid, one of a group of fishes that have evolved a whole bag of tricks for surviving in super cold temperatures, only one of which is their biochemical antifreeze. And they need them because it is cold. The Southern Ocean isn't totally frozen over, but it is covered by sea ice for much of the year. In the coldest waters near the coastline, ice crystals form in the water column and mats of ice blanket the ocean floor. For the fish, there's nowhere to hide. At the risk of stating the obvious, freezing is really bad for most living things. Ice crystals are sharp, and as they form and expand, they can lead to serious tissue damage by basically causing cells to burst and die. But these Antarctic fish are cool with it. They're often found alive and happy, hiding and looking for food right there in the ice. Having ice outside is one thing, but their insides are full of tiny ice crystals too, swallowed from the seawater. And while the freezing point of seawater is minus 1.9 degrees Celsius, the freezing point of the fluid inside a fish's body is in the neighborhood of a degree warmer. That's because the amount of stuff dissolved in water lowers its freezing point, which in chemistry we call freezing point depression. Dissolved salts, like what's in the ocean, are quite effective at lowering the freezing point of water. The fish are only about 1/2 as salty as the sea, so they risk freezing in places where the seawater gets cold enough to freeze. So once that ice gets into the fish, it should freeze from the inside out. Normal freezing point depression isn't enough here. That's where the antifreeze comes in. Specifically, these fish have antifreeze proteins in their bodies. The proteins glom onto the surface of invading ice crystals, completely covering them. Researchers believe the protein actually fits in with the structure of the ice crystals, so that it can bind to them in place of more water molecules and prevent the ice crystals from growing any bigger. Then, the ice crystals hang out in microscopic form in the fish's body, and eventually end up in its spleen, unable to grow bigger and cause the fish any major harm. This antifreeze action is so powerful, it effectively creates a gap in the freezing point of the fish's body fluids between where they should freeze and where they actually do. They lower the fish's internal freezing point by more than a degree Celsius to as low as minus 2.7. Since the seawater can't get much colder than its freezing point of minus 1.9, the fish literally can't freeze. Antifreeze proteins aren't unique to Antarctic fish either. Fish like these, and even some insects, have evolved their own varieties of antifreeze proteins. But while they explain how fish can survive in far-off cold oceans, antifreeze proteins might be closer to home than you realize. They prevent ice crystals from growing too large, and that's an appealing consumer application. Like, ever had ice cream go gritty in your freezer? That happens. It's because the small ice crystals in it have started to grow. To prevent this, some manufacturers actually do add lab-grown fish antifreeze proteins to ice cream to stop ice crystals from growing larger and help ice cream retain its satisfying smoothness. Even more importantly, and yeah, I know, what's more important than ice cream? Research is looking for ways to leverage these natural antifreezes to preserve other types of biological material than the fish that evolved them, like keeping organs for transplants at lower temperatures so they can last longer without being damaged by ice. But that's still a work in progress. The fish, meanwhile, have managed to use some very clever biochemistry developed over millions of years of evolution to survive one of the harshest habitats on Earth. You go, little guys. Thanks to Henry Kai.
Right. It's pretty wild that these fish can make some antifreeze in their own bodies. Even wilder is the fact that they put that chemical in our ice cream. Basically, there's artificial fish in your ice cream. Just fun facts you only learn here at Squam Lakes. And so, yeah, I mean, again, that was a marine fish, and that isn't really an issue for our freshwater fish because we're not getting to those very cold temperatures in our lakes since they are typically inundated with ice on top, which is going to result in kind of like a jacket effect, you know. Yes, me too. Definitely is, I don't know, it's kind of sketchy. What is in our food. All right, so that's fish.
Sir, and Paul Zico for all the great.
Beautiful. All right, on to amphibians. So just have this on the background, turn off the sound so you can look. So frogs and even some salamanders are able to freeze with the change in temperatures. And like our other cold-blooded friends, they are able to reduce their metabolism, so they don't need to remain looking for food and such. And as you can see, this wood frog right here is freezing. It also has the ability to make antifreeze just like that fish before, with chemicals from their livers. I think it's glucose and I forget the other one. But take me out my word, they are able to make antifreeze. So they will overwinter usually either by allowing themselves to freeze in lakes or rivers or creeks and such, or hibernate in the mud and the muck where it's going to be warmer, but still are going to remain inactive, mostly because there's not that much access to food for them during this time. They're also able to like breathe through their skin, so they're able to stay in the water where they're not going to dry out. If they were to stay on the land, they might end up drying out. Although you might find some frogs in burrows, but they're still be able to remain moist in those kind of areas. So those are amphibians. Not too exciting, nothing out there near ordinary. All right, and reptiles, similarly cold-blooded. There's a theme here. With cold-blooded, they can reduce their metabolisms, and so they don't need as much energy to remain alive. And so here's a cool example of a painted turtle that they can actually breathe through their skin as well by opening their capillaries. There's a myth that they can breathe through their butts, which is not entirely accurate. It's more the capillaries in their butt area can provide a lot of oxygen for them to be there. But since they cannot breathe the air, they're not able to be buoyant anymore. They drop to the bottom of the lake. So if you see a turtle at the bottom of the lake, it's likely because they just don't have any air in them, but they're still alive. They're still be able to breathe, at least through the winter. Let me play this video for you.
Painted turtles are found in ponds in many parts of the United States. Baby painted turtles spend their first winters in their nests on land, and when the temperature drops, about half the water in their bodies can freeze. Don't worry, I'm fine. Adult painted turtles, on the other hand, can't survive being frozen. In colder regions, they spend their winters in ponds under the ice. In fact, while underwater, they can switch from breathing through their lungs to taking in oxygen through their skin. But without oxygen in their lungs, they can't stay afloat, so they sink to the bottom of the pond. There's not much oxygen down there, so the turtles can go into a dormant state and live for months without oxygen if necessary. Good night. During their hibernation, the turtles don't eat and instead survive on stored sugars in their bodies. But breaking down those sugars releases acid into their bloodstream. So they release compounds into their blood to partially neutralize the acid, and can also store some of the acid in their shells. Later, they can turn those acids back into sugar. And thus, the cycle continues.
So if you see a painted turtle.
Yeah, so turtle, pretty cool. Able to remain alive through breathing through their skin. Other types of reptiles are not as fortunate as this painted turtle. Think of water snakes and garter snakes that might otherwise be active in aquatic ecosystems. They look for areas where they can overwinter that are going to remain relatively warm and free from the outside elements. So they'll hide in wood piles or stone piles, burrows, or decaying logs, somewhere where they're going to be free from getting too bogged down by the snow or the cold. That's basically what other reptiles are going to do in order to survive. That also applies to amphibians. If they do not want to be in the water, then they'll likely find areas like that where they can overwinter.
Blend of the eye.
Oh, sorry. All right, so we talked about our cold-blooded friends, but what do us mammals and our mammal cousins like the river otter do? We and them have to remain active throughout the winter, or at the very least have enough stored up for the winter. If you think of like bears and stuff that hibernate, you have to go into winter with the ability to survive on the supplies that you already have within your own body. But if you're like a river otter, that you might want to stay active during the winter. So just have this on in the background. If you think river otters are going to try to be around areas that are going to be continuously moving through the winter. I know I've seen river otters down in Little Squam, where past the dam, where the water's continuously moving throughout the winter. And so they're going to be there. They are able to stay warm in the water because they have this special properties in their fur that like are able to like remain slick. So it's not like imagine if you like were wearing a huge down jacket and it got wet. It'd be very difficult to like stay warm in that jacket because it just be too wet. Same as when you wear cotton, you don't want to wear cotton out because if it gets wet and cold, then you might be in real trouble. Otters are able to have this silky kind of, I don't know. Their fur is very specialized for this type of environment. They also have to remain active. They have to go get fish, and so they need to be in these areas. So if you are warm-blooded, you need to either figure out how am I going to stay active during the winter? How am I going to get fish? So they're going to stay around these areas that water remains open. Yeah, so those are mammals in our aquatic ecosystems. And then waterfowl. So I couldn't really find a video for waterfowl because they don't really exist on frozen ponds. Turns out they, what they do is either fly south to other freshwater lakes, or like in the case of the loon, they will fly to the ocean. So loons will actually overwinter on the New England seacoast in order to have access to food. And that's the name of the game. Since birds are like us are warm-blooded, they need to remain active and continue hunting throughout the winter in order to have access to. They don't have the option to lower their metabolism like cold-blooded animals do, so they remain active. And loons are cool in that they are one of the first waterfowl to return to Squam after ice out, like has confirmed. It's that's the Floridian in me. I don't really know all the terms yet. So that is about it. And I just want to close out this presentation with why should we care about this stuff? Like, the reason in years past that, like, there's a lot more data in the literature and in the world about aquatic ecosystems during the summer and spring, because that's when it's warmer and honestly it's when it's easiest to gather data. And so our conception is that there's a lot less going on during the winter than during the summer. And for the most part, that's true, but I think there also is some nuance to that, as we've seen throughout these different examples. It's very difficult to collect data during the winter, as you can think. it takes a toll on the people collecting data. I can speak firsthand to that. You know, we as LRCC members are currently taking water quality samples across the lake, and it is a grueling day of being out on the ice and just being subjected to the elements of wind and cold, and getting a little wet from collecting the water samples. And so it's definitely not something that's fun compared to like the summer months when, you know, you can be like in a short sleeve shirt and enjoying yourself in the sun. It's very different. And as a result, you know, here at Squam Lake Associations, we have like decades worth of data collecting water quality samples during the summer and spring months, but not so much in the winter. Our winter water quality has only started within like the last decade. We've been collecting data, I think within like the last 5 years, really. So that's one point why we should care. We don't know that much yet. And there's still a lot to learn about winter aquatic ecology. And number two, and this is a big one, is climate change is going to change the composition of our winter ecosystems. It's we think of ice out and ice in are going to happen at different times of the year, or like going to start happening later and earlier, respectively. So it's going to ice in is going to be later, and ice out is going to be sooner than usual. So we have shorter periods of ice coverage. And what's that going to mean for our ecosystems? Is there going to be something missing from, is there like a certain like dormancy period that is necessary for like an insect or some special animal that we don't know of yet? And that might have ramifications down the line. We just don't know. And so it's really important that we have people that care about this stuff so that we can continue to conserve it and make responsible decisions in our conservation and management of the lake and other areas, you know, not just here. It can have wide ranging ramifications. But yeah, so those are my thoughts. That's what I wanted to leave with you guys with today. I will open it up to questions if you have any now that we can better cover.
What type of water sampling do you do during the winter?
What water sampling do you do? So there's kind of a two-step process to our sampling process. We use a YSI, which is escaping me what that stands for. But with the YSI, it's basically this little sensor that we put into the water, and we go down 1 meter at a time and take measurements at each meter down into the water column until we're at the bottom of where we're testing. And what we're looking for is dissolved oxygen, conductivity, and anything else? Temperature. And so we're looking for those three things mainly. And so that's with the YSI. And then we take a sample of the water using a plastic tube that we go down into the water column and take like some water from each level and bring it back up real quick, put it into a bottle, and then we come and process it back here at the Squam Lakes Association and send it off to UNH to further analyze. And they're specifically looking for phosphorus levels, and I think phosphorus is the big one.
Sometimes cyanobacteria.
Sometimes levels of cyanobacteria. But yeah, so we're in collaboration with UNH on that, with the more chemical side of it. But yeah, that's what we're doing.
Thank you.
Oh yes, of course. Any other questions?
Hi.
Hi.
I was wondering if there are any amphibians that would live in a small pond, like a 10 by 15 3-foot pond, would they live over the winter?
So a lot of amphibians will, most of them are not going to do well in the winter, which is why most of them are going to be like dormant, and like a lot of them will bury themselves in the mud and the muck. You think of like salamanders, stuff like that. They'll usually reemerge in the spring when it's warmer and vernal pools start to open up. Yeah, so they're really not going to be active this time of year. And you know, as you can, if you hear at night, there's no frogs croaking or anything like that. It's really, they need it to be a lot warmer for them to be active. But they are alive. They're just not doing anything.
Even under the snow, like my pond's under a foot of snow right now, it's still,
Yeah, I think it's just far too cold for them. You know,
yeah, okay,
yeah.
thanks.
If they were to exert that energy, it would be not beneficial to
Okay,
them.
I won't put any in there.
Yeah.
Thank you.
No worries. I'm so glad you learned something. So glad to hear that. Even
Well, the whole water flipping thing, that was amazing. I never
yeah,
heard of that before.
it is really crazy. Like I also, it's what I love about putting on these adventure ecologies is that like it really challenges me to learn a lot more than I was aware of too. Because again, I am from Florida. We don't have much
Yep.
seasonality down there, so it's like never really crossed my mind. You know, I grew up going to the Everglades, and I could go there, you know, in December, in January, in shorts and a short sleeve T-shirt, and it'd be amazing. But that is not the case here. So it's very different. And getting to learn about like how, you know, lakes themselves have lives and like can change throughout the year is pretty amazing. I
Yeah,
agree. Yeah.
we're lucky we have very clean lakes here.
Yeah. No, Squam Lake is particularly very clean too. I know as part of our like onboarding material, we had to like review some of our past water quality assessments and stuff, and it's very like with some exceptions, there are like it's a very pristine lake, and that's largely due to the efforts of the nonprofit that we work at
Yep.
and other informed individuals like you in the community that take part in making sure that it stays this way. So you definitely love that everyone takes their, you know, does their part in maintaining it like this.
Yes.
Yeah, yeah. The cold is very different, but I actually was here in southern New Hampshire last winter as well, right before the pandemic hit, and I did move back home for a little bit, but was lucky enough to land here at Squam Lakes. So happy to be here.
Nice.
Yeah.
Well, we're glad you're here.
Thank you so much. All right. So if there aren't any more questions, I think we might end it here. I actually do have, I do have some polls that I would love for you to answer. Oh, never mind. There are some metric data that I would love to collect from you guys, just as when we write our grants and stuff, we need to record who is learning material from us, and so that we can put it into our next grant write-in that we do. So if in the chat, you could just answer this question I'm going to come up with in a second. Oh, yes, since November, I'll also type it down. Since November, is this your first program? Bear with me 1 moment. The polls don't work. Okay. All right. And So this is, so I wrote in the chat, since November, is this your first program you've attended with SLA? And we just need this as a metric to see how many people we're reaching. And it's a good way to record that. So you can either, I would love if you could just say yes or no in the chat, so we can write that down. And thank you all for those of you who are joining us for the first time. That's really amazing. There are quite a few of you. Really appreciate you taking the time out of your Saturday to do that. Once you write that down, you're free to go. And I really appreciate your time and dedication to preserving the Lakes region in New Hampshire.
Thank you.
Thanks.
Great job.
Thank you.